We're going to talk about radians on the unit circle. So we learned in the last video about what is a radian, how to convert from degrees to radians and radians to degrees. And now we're just going to focus on the unit circle with this video. So a quick refresher, why is 362 pi? Well, remember, the radius on here is 1, and so the circumference would be pi times the diameter. And so if we go all the way around this circle, there's my little green all the way around. That was terrible. Anyway, the diameter is going to be 2. So the circumference is pi times 2, or as we call it, 2 pi. So the radians is how far around the unit circle we go. So if we're only going halfway around the unit circle, that's just going to be 1 pi, or pi. And then we talked also about what if we only go a quarter of the way around? Well, that's halfway to pi, so that would be half of pi, or pi over 2. And so let's expand on this. I just wanted a quick recap why 2 pi is 360, but look at the unit circle, and let's talk about ways that we can identify all of these angle measures around the unit circle. So let's start with the ones we know. 0 is 0. 360 we just said is 2 pi. 180 we said is pi. And 90 is half of that, so we said pi over 2. So then really what we're going to really focus on are these 3. And once we get those 3, then we can kind of build on those to figure out the rest of them. So, and really all you really need are these 2, but we'll get those 3 and I'll explain why those 2 are really the only 2 you need. So let's start with 30. 30 goes into 180 how many times? And so if you think 30 times what is 180, or you could just do it, you could do 180 divided by 30, and if you punch that into a calculator or you actually, figure it out in your head, that's 6. And so 30 is 1/6 of 180. So that means it's 1/6 of pi. So we've got pi over 6. So 30 is going to be pi over 6. Those are the same thing. 30 degrees, pi over 6 radians, those are the same. Okay, for 45, that is going to be, what fraction of 180? Well, how many times does 45 go into 180? You could do the dividing thing again, or you could think like, well, this is 1, another 45, another 45, another 45, and so how many times did we rotate 45 degrees to get to 180? Well, that was 4 times. And so that means that 45 is 1/4 of pi. So it'll be pi over 4. If that didn't make any sense, really all we're doing is 180 divided by 45. That's 4. And that tells me that this would be 1/4 of 180. Okay, let's switch up colors here. Let's go to, we have purple? Yeah, let's go to purple. So 60 goes into 180 how many times? Well, it's 3 times. If you don't believe me, you can plug it in your calculator, do 180 divided by 60. And so 60 is pi over 3. So what we have here is we have our first quadrant set. We know those 3 angle measures in radians now. 30 is pi over 6, 45 is pi over 4, and 60 is pi over 3. Well, all the rest of them are just multiples of these 3. And like I said earlier, they're really just multiples of 30 and 45, because 60 is a multiple of 30. So you can think of these 3 that we found, 60, 45, and 30, or pi over 3, pi over 4, pi over 6, and you can expand that out. So like 120 is 2 60s. All right, let me say that again in case you missed that. 120 is 60 times 2. Hopefully that makes sense. So it's going to be 2 of the pi over 3s. So the way we write that is 2 pi over 3. Not super complicated, hopefully. It's 2 60s, so it's 2 pi over 3s. So we write 2 pi over 3. 135 is going to be 45 but it's going to be 3 45s because we go 145 and then 2 45s is 90 and then 3 45s is 135. So this is going to be 3 pi over 4. 150 is going to be 30 5 times. 30 times 5 is 150. So it's going to be 5 pi over 6s. Now, another way you could have looked at 120 is you could have said, well, 120 is 4 30s, and so that would be 4 pi over 6. But guess what? That reduces down to 2 pi over 3. So if you want to think of it in terms of multiples of 30, that's totally fine. Then you just have to reduce the fraction. That's all. Okay. Now these numbers are going to start getting a little bigger, so the mental math is maybe going to be a little bit more challenging, but we can do it, right? 21 and 3 are 210 and 30. How many times does 30 go into 210? Or how many times does 3 go into 21 is really what we're looking at, and that would be 7 times. So this would be 7 pi over 6. If you're not sure where I came up with that, another way to think of this is 210 divided by 30 is 7. So you take the angle measure that we're trying to figure out, divide it by either 30 or 45 or 60, and see if you get yourself a whole number. And for all of these, you will get a whole number for one of those 3 angle measures. Okay, 225 is 45, and let's see, it was 45 at once, twice, 3 times, 4 times, so 5 times, that'd be 5 pi over 4. 240 is, let's do 30, even though that's not the one I would normally choose. So we've got 30 once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. So this would be 8, oops, got ahead of myself, 8 pi over 6, because it's 8 30s, and 30 is pi over 6. Well, 8 pi over 6 can be reduced, so this would be 4 pi over 3. If you noticed that 240 is a multiple of 60, you could have also done that. It's 4 60s. Okay, 270 is 3 90s, and so if it's 90 is pi over 2, then it's going to be 3 pi over 2. Once again, 90 times 3 is 270, so that would be 3 pi over 2's, which is 3 pi over 2. Okay, 300, so 60 goes into 300 5 times, so this is going to be 5 pi over 3, because 60 is pi over 3, and it'd be 5 of those. 315 is 45 7 times. If you're not sure, it would just do 315 divided by 45, which is 7. So this would be 7 pi over 4. And then the last one, 330, is, well, how many times does 30 go into 330? If you cancel out 10, you get 33 over 3, which is 11. So this would be 11 pi over 6. And that's really the main idea for today, is what are all of these values on the unit circle? Hopefully, I explained it well enough where if you had to recreate this, you definitely could. Eventually, you're going to get really good at this. Somebody's going to say 2 pi over 3, and you're immediately going to think that's 120. Or they're going to say 5 pi over 3, you're going to say, oh, that's 300. Like, these are going to be synonymous in time. Right away, though, they're not synonymous. It takes some time to get familiar with them. But with enough repetition, you're going to get really comfortable with which radian matches up with which degree. So what we're going to do with this, the next, is basically what we did in last week, where we're doing sine, cosine, and tangent of different angle measures. But instead of saying sine of 60, where we look at the y value for 60, we're going to say sine of pi over 3. So just a quick reminder here, sine of an angle, I don't want to use x, sine of theta is the y value, and cosine of theta is the x value, and tangent of theta is y over x. Those three things we talked about previously. So if we do sine of pi over 3, that is the same as sine of 60. And since we're looking at the y value, the sine of pi over 3 would be root 3 over 2. So if we go over here, this is just root 3 over 2. And that's it. So it's the same kind of idea of what we did with the previous homework. The only difference is we are doing it in radians and not degrees. Okay, next one, cosine of 2 pi over 3. So 2 pi over 3 is right here. And we're going to do the cosine value, which is the x value, and that's negative 1/2. Oops. All right, how about cosine of pi? So if we do cosine of pi, that's right here. Cosine is the x value, so this would be negative 1. What about sine of 2 pi? 2 pi is the same as 0, or it's not the same as 0. It's the same ending value or coterminal angle as 0, but 2 pi is one rotation around. And so sine is the y value. This would just be 0 because the coordinate is 1, 0. Okay, and then into the slightly more challenging ones, tangent of pi over 4. So here's pi over 4. That is 45 degrees. So tangent is root 2 over 2 divided by root 2 over 2, which is just 1. And then lastly, tangent of 11 pi over 6. So it's going to be this one I'm putting in purple. Tangent is y over x, which in this case is negative 1/2 divided by root 3 over 2. And when we divide fractions, remember we keep the top one the same, but then we multiply it by the reciprocal. Whoops, I wrote that wrong. 2 over root 3, the reciprocal of the bottom. So we're going to flip the bottom, multiply across. This becomes negative 2 over 2 root 3. We can reduce the 2 over 2 to 1 over 1, so this would be negative 1 over root 3. And then we get rid of the square root in the bottom by multiplying by root 3 on top and bottom. And we end up with negative root 3 over 3. So the answer is negative root 3 over 3. Okay, so this is really our task for today, is applying what we did last time around with sine, cosine, and tangent on the unit circle. But the only difference is we're going to be using radians. All right, so that's it for radians day number 2.